Modern atomic theory. The findings of modern atomic theory are given as follows. Atom is considered to be a divisible particle because in the John Dalton period, atom is the smallest indivisible particle, he said. But in the Rutherford, J.J. Thomson period time, atom is the considered as a divisible particle. It consists of three particles, namely proton, electron and neutron. Suppose the atoms of the same element may not be similar in all respects. Isotopes. Isotope means some elements are existing same atomic number but different mass numbers. This phenomenon is known as isotopes. Suppose the element existing same mass number, different atomic number are called isobars. Both of them are differ mean same different atomic number and different mass number mean or different number of neutron mean, that is isotones. Atoms of different elements may be similar in some respects. Example, isobars. Here the example for isobar is if it possesses same atomic mass or mass number and a different atomic number, and this phenomenon is known as isobars. So the example for isobar is argon 1840, calcium 2040, both of them possess same mass number, that is 40, but it differs in their atomic number 18 and 20 respectively. Atoms is the smallest particle which takes part in chemical reactions. The ratio of atoms in a molecule may be fixed and integral but may not be simple. So, C12H22O11, that is sucrose, is not a simple ratio. Here, atom is the smallest particle. It is a divisible particle. It consists of three particles, namely proton, electron and neutron. Already we discussed. These atoms of the smallest particle only involved in chemical reaction. So, the ratio of atoms in a molecule may be fixed or integral but may not be simple. Example, sugar. Sugar is nothing but sucrose, C12H22O11. It is not a simple ratio. Here the ratio should be differ. Atoms of one element can be changed into atoms of other element by transmutation. Here one element of atom can be changed into atoms of other element by transmutation process. The mass of an atom can be converted into energy. This is in accordance with the Einstein equation E equal to mc squared. Here, whenever nucleus is formed, some amount of mass can be converted in the form of energy. So, this is called a mass defect. So, the energy and mass should be given a relation based on Einstein equation E equal to mc squared. E refers energy of an electron, m refers mass of electron, c refers velocity of light and its value equal to 3 into 10 power 8 meter second inverse. This picture shows that Einstein, he is a famous scientist. He was awarded by Nobel Prize because he discovered photoelectric effect. So based on photoelectric effect, he was awarded by Nobel Prize. He gave a famous equation which is known as E equal to mc squared. Avogadro's hypothesis. Hypothesis means theory. Hypothesis means theory. So Avogadro put forward a theory which is known as Avogadro hypothesis. Amedeo Avogadro put forward a hypothesis based on the relation between number of molecule and volume of gases. Here, how the number of molecule and volume of gases can be related. So he explained with the help of suitable illustration. Technical file on Tamil Tanki. Avayar, in the praisal of Thirukural, one can find Avayar saying that Valluvar pierced an atom and poured into 7 seas of wisdom. Avogadro's law, equal volume of all gases under the same condition of temperature and pressure contain the same number of molecules regardless of its nature. Here the photo shows that Avogadro's law to deduce atomicity. What is meant by atomicity? The number of atoms present in one molecule of an element is called the atomicity of an element. So, for example, in hydrogen, nitrogen, chlorine, bromine, these are considered as diatomic molecules. So, their number of atom is 2. So, the atomicity value is 2. Whereas helium, neon, argon, krypton, xenon, radon, these are considered as monatomic gases. So, their atomicity value is 1. Whereas ozone, O3, here it contains 3 oxygen atoms, so its atomicity is 3. So, atomicity can be defined as the number of atoms present in one molecule of an element is called the atomicity of an element. Depending upon the number of atoms in one molecule of an element, molecules are classified into monoatomic, diatomic, triatomic and polyatomic molecule. Here the example for monoatomic molecule is it contains only one atoms are packed here. So that is called monoatomic. So here the picture shows that monoatomic gaseous molecule. Diatomic means it contains two atoms. For example, hydrogen, chlorine, bromine, iodine. These are considered as diatomic molecule. It contains two atoms. Triatomic means carbon dioxide, CO2. It has linear shape because carbon and oxygen possess double bond, whereas here also carbon and oxygen possess double bond. So it is arranged in linear form. Tetrahedron. Water is the example for tetrahedron. Electron pair geometry. Bent shape. It has bent shape. Whereas nitrogen dioxide trigonal planar electron pair geometry. So these are the examples for triatomic molecule. Triatomic molecule means it contains three atoms placed in a molecule called as triatomic molecules. Polyatomic molecule means more than two or three atoms placed in it called as polyatomic molecule. Different molecules are close together. So for example, hydrogen chloride. It is a polar molecule because hydrogen carries positive charge whereas chlorine carries negative charge. Non-polar molecule means CHCl4. Carbon tetrachloride is the non-polar solvent. Ammonia is the polar solvent because it possesses positive charge. Then polar nature. Methyl chloride is the polar molecule. Boron trifluoride is the non-polar molecule. Boron carries positive charge, fluorine carries negative charge. For a given substance, atomicity can be deduced using the formula atomicity equal to molecular mass by atomic mass. For example, here oxygen O2. Here in O2, their atomic mass is 16, whereas the molecular mass is it is a diatomic molecule 16 into 2 32. So here the molecular mass of oxygen is 32 divided by atomic mass for oxygen is 16. So equal to 2. So the atomicity for oxygen is 2. So atomicity can be calculated using this relation. Atomicity equal to molecular mass